Welcome to fennaelearning. The title of the project is Automatic Cardiac Health Recognition System based on ECG signals. The objective of the project is to design an effective method for the automatic recognition of myocardium dysfunctions based on ECG signals. Discrete Fourier transform and Welch method is used to obtain the spectral power density of the ECG signal. K nearest neighbor classifier is used to identify the cardiac health condition based on the extracted features. Motivation of the project. From social point of view, it is extremely important to prevent the heart diseases, which are the most common cause of death worldwide. According to a recent survey, 50 million people in the world are at risk for cardiac diseases worldwide. These are the literature's paper related to the project. In the first paper, spectral power density is estimated from the ECG signal, and the classification operation is performed using support vector machine and radial basis feed-forward neural network. The major limitation of these works are clinical trials of ECG signals is not performed. In the second paper, empirical mode decomposition and temporal features are analyzed. Normalized cross-correlation based beat classification is performed for EEG classifications. The major limitation of this work is the noise ECG recording environment signals are not analyzed in the work. Filters are not properly used to remove the noise from the ECG signal. So the third paper, the method used is smoothing operation to remove the high frequency noise from the desired signal. Then sliding window approach is used for QRS detection. The major limitation of the work is the computational cost of the work is high. This is the flowchart of the proposed method. We have to give raw ECG signal as input signal, and in the first step we have to pre-process the EEG signal. After pre-processing step, we have to extract the features from the different power spectral density. Then KNN classifier is used to classify normal EEG signal and abnormal EEG signal. Pre-processing step. This stage aims to unify the data from various ECG devices. The main steps involved in pre-processing are gain reduction, frequency uniformity, constant component reductions, and rescaling. So this is the normal signals and abnormal ECG signals from the database, and this is the pre-processed ECG signal database. So in the pre-processed output, there is a scaling in amplitude and there is a scaling in the time frequency components. The next step is feature extraction. The feature extraction is a process of dimensionality reduction by which the initial set of raw data is reduced to more manageable groups for further processing. The aim of this stage is to extract and strengthen the characteristics features of the signals and thereby increase the recognition efficiency. Feature extraction facilitates the speed of learning and generalization steps in the machine learning process. So Welch method is used to determine the power spectrum of the ECG signal. It converges to the true power spectrum density. The main steps involved in Welch spectrums are explained below. In the first step, we have to divide the time domain signal into successive blocks with overlapping. In the second step, the overlapped block signals are then windowed using Hamming window. In the third step, we have to compute the periodogram of each block. In the fourth step, we have to take the average of the periodogram of each block to determine the Welch spectrum of the ECG signal. So this is the mathematical representation of Welch method. So in the first step, the given signal x of n is divided into successive block by using the formula xi of n equal to x of n plus im. Im represents the successive blocks. The second step operation is explained in this equation. So the windowed signal is given by xi w of n equal to w of n x of n plus im. So x of n im is the successive block signal. That signal is multiplied with the Hamming window function w of n in the second step. The third step is we have to compute the periodogram of each block signal. So the xi w of n is the windowed signal. So here this xi w of n is multiplied with the basis function e power minus j 2 phi fn to obtain the periodogram of each block of the signal. The fourth step is to determine the Welch power estimate, and this Welch power estimate is obtained by taking average of this periodogram function. So that is expressed by this equation Px of Wf is equal to 1 divided by k summation I equal to 0 to k minus 1 Px of W of I into F. After obtaining this power spectrum of this ECG signal, the statistical properties such as mean, variance, autocorrelation are measured from the estimated signal. So this is the output of Welch power spectrum estimation, and the peak points in the spectrums are indicated by green lines. The final stage of the project work is to design the KNN classifier. So k nearest neighbor is a non-parametric machine learning method, and this algorithm is based on similarity measure between the new data and the available trained data. So this classifier compares the new features with the already trained features in our database and find the similarity between the new data and the trained data. These are the major steps involved in KNN classifier. In the first step, we have to select the k number of neighbors. The second step, we have to calculate the Euclidean distance of k number of neighbors. Take the k nearest neighbors as per the calculated Euclidean distance. Among these k neighbors, count the number of data points in each category. Assign the new data points to that category for which the number of neighbor is maximum. And the final step, we get the classification result. The performance of this project work is measured based on specificity, accuracy, and sensitivity. The accuracy parameter is defined as the ratio of correctly detected ECG signals to the total number of ECG signals. Thank you for watching this project video. Kindly subscribe, share, and support the project.